Lesson 8-3 is on special right triangles. Consider a square. It has all four sides congruent and all four angles measure 90 degrees. Notice what happens when we draw a diagonal. Since the diagonal bisects opposite angles, we have two 45-degree angles. We call this a 45-45-90 right triangle. The legs are congruent. Let's call them each x. And we need to find the length of the hypotenuse. We'll call it c. So using the Pythagorean theorem, the length of the hypotenuse, c squared, equals x squared plus x squared. The two legs are the a and b of the Pythagorean theorem. So c squared is equal to 2x squared. And taking the square root of both sides, c is equal to x, because the square root of x squared is x, times the square root of 2. What this means is that the length of the hypotenuse is the length of a leg times the square root of 2. So whatever the length of a leg is, the hypotenuse is that number times the square root of 2. Here's a little formula for you to memorize. Hypotenuse equals leg times the square root of 2. And that's going to be true for all 45, 45, 90 right triangles. Let's take a look at a couple examples. So example number 1, we have a right triangle, and we know it's a 45, 45, 90 because the two legs are both 5. And we need to find x, which is the length of the hypotenuse. Using our formula, hypotenuse equals leg times the square root of 2. Now just plug in the numbers. The hypotenuse is x, the leg is 5, and square root of 2, which gives us our answer. So x is equal to 5 square root of 2. Here's another 45, 45, 90 right triangle, and I know it is one because these little arcs in the corners tell me, and the angles tell me that these two angles are congruent, and they must be 45 degrees. In this case, we know that the leg is x, and the hypotenuse is 6. So using our formula, hypotenuse equals leg times the square root of 2. The hypotenuse is 6. The leg is x times the square root of 2. Now we need to solve this for x. Let's divide both sides by the square root of 2. So that gives me x equals 6 over the square root of 2. And remember your rules about radicals, that you cannot have a radical in the denominator. So we need to rationalize the denominator by multiplying top and bottom by square root of 2. And that gives me 6 square root of 2 over 2, because square root of 2 times square root of 2 equals 2. And now I can cancel the stuff that's out front. So that becomes a 1, that becomes a 3. So x is equal to 3 square root of 2. And our last example for this triangle, here I have another 45, 45, 90 right triangle. And I know that because I have a 45 written in one angle, so the other one must also be 45. Now I know that a leg is 7 square root of 2, and I don't know what the hypotenuse is. So let's use our formula. Hypotenuse equals leg times the square root of 2, or x equals, the length of the leg is 7 square root of 2 times another square root of 2. So x is equal to 7 times square root of 2 times square root of 2 is 2, or x equals 14. Our second type of special right triangle starts with an equilateral triangle. So let's consider an equilateral triangle. Again, all three sides are congruent, and all three angles are congruent. Each angle measures 60 degrees. So when we draw an altitude from the top, perpendicular to the bottom of the triangle, notice that it's going to bisect the top angle, and it bisects the two bottom sides. So these two angles are congruent to each other, and these two segments are congruent to each other. That gives us a 30, 60, 90 right triangle. When we bisected that top angle, each of those became 30s, and we know that this angle of the equilateral triangle was a 60. So we call this a 30, 60, 90 right triangle. The hypotenuse of this triangle is one side of the equilateral triangle, and the shorter side, which is the bottom here, is opposite the 30-degree angle. The length of that is actually 1/2 of the side of an equilateral triangle. So to make this a little easier, let's call that one x, and let's call this one 2x. Because remember, when we dropped the altitude, we bisected the bottom segment of the triangle. So we need to find the length of this longer leg over here. Again, we're going to use the Pythagorean theorem, so let's call it a. So a squared plus x squared equals 2x squared. Notice that I put the 2x in parentheses because I want 2x times 2x, which gives me 4x squared. And solving for a, when I subtract x squared from both sides, I get 3x squared. Actually, I think I'll move that down a line. And then we're going to take the square root of both sides, and that gives me a equals, the square root of x squared is x, and the square root of 3 just stays the square root of 3. So the length of that longer leg is x times the square root of 3. Notice that x is the shorter leg. In fact, maybe I'll go ahead and label those. This is the shorter leg, this is the longer leg, and this is the hypotenuse. So we can actually come up with a couple formulas for this triangle. So the hypotenuse, which is 2x, is equal to 2 times the short leg. And the long leg, which we solved for a, the long leg is equal to the short leg, which was x, times the square root of 3. So here are two short little formulas to memorize for a 30, 60, 90 right triangle. The hypotenuse equals 2 times the short leg, and the longer leg equals the short leg times the square root of 3. Let's do a couple examples to see how we're going to use these. Okay, so in this triangle we know it's a 30, 60, 90 because we have a 90-degree angle here and a 60 here, so the other must be 30. If it helps, you can actually label them. This is short leg, this is long leg, this is hypotenuse. And let's see what we know. I know the length of the short leg. So I'll start with hypotenuse equals 2 times the short leg, or y equals 2 times 7, or y equals 14. Okay, I'll use my other formula. Long leg equals short leg times the square root of 3. My long leg is x. My short leg is 7 times the square root of 3. Okay, so x equals 7 times the square root of 3. This is probably the easiest case where they give you the short leg and you have to find the other two. In this triangle, we're given the hypotenuse and we need to find the short leg and the long leg. So I'll start with the formula. Hypotenuse equals 2 times the short leg, or 12 equals 2 times x, and dividing both sides by 2, x is equal to 6. Okay? I can actually plug that in here. Maybe that'll help me a little bit. Other formula, long leg equals short leg times the square root of 3. My long leg is y. My short leg I just found is 6 times the square root of 3. Okay, and the last example, we're given the length of the long leg, and we need to find the length of the short leg and the hypotenuse. So I've got my two formulas. Hypotenuse equals 2 times the short leg, but I can't start with that one because I don't know the hypotenuse and I don't know the short leg. So I'll have to use my other formula first. Long leg equals short leg times the square root of 3. My long leg is 9. My short leg is x times the square root of 3. Now let's solve this for x. Divide both sides by the square root of 3. So x is equal to 9 divided by the square root of 3. And again, I can't have a radical in the denominator, so I'll have to rationalize that by multiplying by square root of 3 over square root of 3. And that gives me 9 square root of 3 over 3. And I can reduce the 9 outside the radical sign and the 3 on the bottom. So x is equal to 3 square root of 3. And that's my short leg. So now I can go ahead and use that in my other formula here. I don't know the hypotenuse, but I do know the short leg. 2 times 3 square root of 3, which gives me 6 square root of 3. Okay? And I didn't say this earlier, but for all of these, I prefer exact answers. Answers that have square root of 3 and square root of 2 in them, if those come up. Don't round. Give me exact answers. So to summarize, here are the little formulas you should really memorize. For a 45, 45, 90 right triangle, the hypotenuse is equal to the length of the leg times the square root of 2. For a 30, 60, 90 right triangle, the length of the hypotenuse is 2 times the length of the short leg, and the length of the longer leg is the length of the short leg times the square root of 3. Memorize those.